Good morning. Woo! Let's see, what's it? Wednesday morning. Fantastic. All right, before we get started, my attorneys advise me to advise you before you purchase any of our products or stock or spend money in any other way that you should base that on what we have generally available in our product today, not necessarily what I'm about to show you today, because at the end of the day, I go by MJ Freshy Fresh. I'm not sure you want to trust that guy. So, global warming has impacted our planet in numerous ways. Perhaps it's responsible for the unprecedented number of great white sharks we're seeing swimming off the coast of North America today. However, an accurate source of great white shark counts doesn't really exist. And this has left marine biologists scratching their heads trying to understand this phenomenon, and it's left the general public a little bit concerned to go in the water. So we partnered with the Benioff Ocean Initiative and UC Santa Barbara and asked, how can we use computer vision to help keep our beaches clean and safe? For those of you that don't know, the Benioff Ocean Initiative, you should recognize the name Benioff. That's our CEO, Mark. This is a foundation he created in conjunction with UC Santa Barbara, essentially focused on bringing technology to solve some problems in the ocean. I did want to mention they actually just started another grant. It's a $3 million grant where essentially it's an RFP. So various people are now submitting ideas. The current focus is around keeping plastics out of the rivers. So if you are interested in learning more about BOI, I'd encourage you to check out the website, boiucsb.edu, and you can find out a lot more about that. This is the group that we partnered with on this project. And so a little bit about who we are. So my name is Michael Jones. I go by MJ. You can find me at MJ Freshy Fresh pretty much everywhere. I work for Richard Socher. Richard Socher is our chief scientist. Those of you that have watched sort of the Salesforce acquisitions, you may remember a company called MetaMind. In 2016, we acquired a company called MetaMind based in Palo Alto, led by Richard Socher. Richard is famous for bringing deep learning techniques into natural language processing and computer vision. I guess I'll start by saying, how many people know what deep learning is? Mixed. All right, good deal. So deep learning, very interesting. If you sort of think about machine learning prior to deep learning, if we were going to build, let's say we're going to build a classifier for a cat, you would essentially start by defining ears and whiskers and nose. And that's how you traditionally build a computer vision model to classify a cat. But then let's say you find a cat that lost its ear, poor thing. Then your model wouldn't necessarily work. And so how deep learning differs is rather than you defining what those features are, deep learning is essentially where the machine learns it itself by you giving it a lot of examples. So sort of think about teaching your child, cat versus dog. You need to show them a lot of cats and a lot of dogs. And so deep learning, not new, it's been around since the 60s. However, with the sort of tremendous amount of data and compute we have now, we're now seeing a lot more breakthroughs with deep learning. And so Richard Socher took deep learning and applied it to natural language processing. And actually one of the funny things is he originally applied for a natural language processing convention and wanted to bring one of his deep learning papers. And they said, no, you can't bring that. That's not natural language processing. And so it's really funny now because today, so many people are using deep learning for NLP. If you do watch the news, you've probably seen BERT, one of the newer language models. So there's a lot of awesome stuff going on in deep learning. As far as our research team, you can kind of think of our research team as having three different constituent parts. We do have a pure academic research team, and they are publishing papers, beating state of the art, and going to conferences. We have an applied research team, and this is what really excites me. Applied research is essentially where AI research meets our customers and their businesses. And so that excites me because we're solving real world problems. And then we have a third sort of leg at our research team called the AI for Good. And AI for Good, our mission is essentially taking state-of-the-art artificial intelligence and doing some good in the world. And so the project that I'm going to talk to you about today falls into this AI for Good bucket. But I did want you to sort of understand the breadth of our research from academic to applied to AI for Good. So, as we met with Benioff Ocean Initiative and worked with UCSB, we developed a Salesforce solution. And so this essentially shows you the key elements of the solution we're using to count sharks today. And so this starts with data collection using drones, which is pretty darn exciting. We have AI and autonomous monitoring. We have a whole back office dispatch system, and ultimately we have workers in the field that have mobile applications that this intelligence is being pushed to them. And so essentially this is the stack, and today we'll go through and unpack this further. For those of you that know the Salesforce ecosystem very well, this is actually built on what we call Field Service Lightning, or FSL. I'm kind of curious, how many people have heard of Field Service Lightning? Oh, good group, yeah. I'm silly, I've been at Salesforce over 4 years. This is one of my first encounters with Field Service Lightning. I must say I love it because ultimately with Field Service Lightning, this is taking action in the real world. I started my career as a developer, making dots light up on the screen, and so having spent a long time making dots light up on the screen, it's really awesome to do things in the real world, and that's what Field Service Lightning enables you to do. And so being in AI, I do get a lot of flack about taking jobs, and I think all of you in here are aware of that. We're aware that, as we move into this future, some of the current jobs may not necessarily exist. And so what I was really happy is as we were building out this solution, we started to discover net new jobs. And so I'd call your attention to this fella here in the middle, the data collector. This is a certified drone pilot. And as we started creating this solution, we realized this is going to be a key person, a key individual on the team to collect data. And as I further studied this, I found out that FAA believes there's going to be the need for 500,000 certified drone pilots by the year 2020. So that's actually going to be a big new job. And so it's exciting as we start to use the tools and develop the future that we start to uncover future jobs. Drones have been very interesting. I don't know about you all, but I remember when they kind of took off many years ago, and I had a little tiny one that I had a great time crashing and flying. But drones are really advanced today, and so a lot of people, I get a lot of questions like, MJ, what drones are you using? Most people think we're using some big commercial solution, but we're not. We're actually using the DJI Mavic, sort of over there on the left. It's your basic hobbyist drone, and we're using your basic hobbyist camera. So we have used some more advanced thermal imaging cameras and a variety of software, but at the end of the day, we wanted to make this technology accessible to the most people. And so we chose a hobbyist level drone with your basic camera. Beyond that, there's some pretty phenomenal stuff in the commercial space. There are what they call fixed wing drones, and so you can imagine those will stay aloft a lot longer. They'll actually go run their own patterns. They'll come back home and feed. It's pretty amazing, but for the purposes of our project, you can use your basic off-the-shelf hobbyist drone to collect the data footage. And so getting into the story, those of you that know Field Service Lightning, there is a dispatcher component there. And essentially, this is our back office dispatch. This is ultimately routing the right people to the right place at the right time. And so that begins with data collection, but what that may then move into is taking action with the data. So this is a view into the back office dispatch component. Building on the platform, I think a lot of people hear the word platform and do understand the power of the Salesforce platform. And that's why I was really excited to build this on Field Service Lightning, because by building this on Field Service Lightning, I didn't have to be a mapping expert. I didn't have to build new components. This is actually built directly into Field Service Lightning. FSL looks at things, what they call assets. And so as we explored creating this solution, what we realized is a beach that we're monitoring for sharks actually is an asset. And so here you can see essentially across the territory, it'd be San Francisco territory, we rolled up a variety of different assets. So building on the platform gave us tons of upside. This is so that we can get the correct data collectors to the correct beaches to monitor it. So a sort of a map view inside of FSL. So getting started with our data collectors, this is where I'd say the story begins. Essentially, we have a beach that we want to monitor. And so we have a collection of certified drone pilots. So we use FSL to activate them, to ask them to go collect some data on that beach. And I do want to pause here because I've got a lot of hands where it seems like you all do know a lot about Salesforce. And I'd say at Salesforce, we have a lot of shiny slides that look really nice that don't necessarily always map to product. And so here I wanted to put, this is a real picture, folks. So thus far what you've seen is our amazing design team that does an amazing job. But this is actually us on site. So this is us getting out in the field. The fellow on the right, this is Francis Joyce. He's a researcher there at UCSB. The two men in the uniforms, these are actually lifeguards. I didn't, most people think Baywatch, but no, those are lifeguards. And then the woman in the green is with the wildlife group. And so essentially, they're very interested in this project. As lifeguards, they're responsible for monitoring that coastline, and they realize the power of this technology to give them intelligence about the coast that they're surveying. And so these are the people that we're partnering with. Ultimately, we're taking the shark count data and we're making it available to them as well. And so it's been fun getting out in the field. Ultimately, those of you that are building product, building on the Salesforce platform, there's an old adage called get out of the building. And it's one thing to sit there in your office and design beautiful things, but I'd encourage you, get out, go see the users. Who are the end users? What are their problems they're encountering? What do they do before they use your application? What do they do after they use your application? Getting that sort of intelligence in the field will really change what you develop. So I'd encourage you to do that. For the lifeguards, it was interesting talking to them. They said, MJ, what you're building, we believe is the future. They said, most people think lifeguards run the beach to stay in shape. They're like, but we don't do that. Like, we run the beach to get situational intelligence. When you see the lifeguards running, it's not for them to stay in shape. It's so that they know the beach. So they know what's up on shore, so they know where the big holes are, the trees are, and everything else. And so they said they can imagine in the future, they might begin their day by running a drone survey. They might come in and instead of go running, they might hit the button and have the drone go fly the survey of their beach. So those of you that are developing your software, I encourage you, get out of the building. This is my photograph to say, no, it's real. We're currently still in a beta testing phase, so we're improving the model, which I'm going to show you some model results. And ultimately, we're looking at launching this summer. So summer is when we want to go GA, and our plan is to run this for 1 year. So survey data for 1 year, so we can get some of the sort of the seasonality to these shark populations. So back into the pretty slides. As a drone collector, as a data collector, you're going to have a field service Lightning app, and you're going to have an appointment like this one. And we're going to say, hey, can you go to this beach and fly and collect some data for us? And so one of the things with AI, actually one of the things with anything you develop, you've all heard the old adage, garbage in, garbage out. And so as you're building algorithms, particularly AI, you need to put the best possible inputs into that algorithm. And so that's what we talk about, your consistency of data collection. And that's why I was really happy about the Field Service Lightning platform. Again, here, this is what we call our survey methodology. And we've actually been developing this, honing this, of like, how high do we fly the drone? How fast do we fly the drone? How big a survey do we make? And so ultimately, that is important as you're building AI to give it the best possible data to go analyze. And so we are embedding our survey methodology directly into the application so that we can ensure consistency of the data collection. Another thing is flows. And so as people are going out in the field and collecting the data, we want to ensure consistency and safety. And so we're able to embed the flows of exactly what you do when you go fly your drone or other activities. Again, the power of the platform. It's really great when you're building on that and we can ensure that consistency and safety. So imagine you're the drone pilot, you got that push notification, you went out to the beach, you took your drone, you flew your survey and you followed the survey methodology, you then upload the video. So here we can see the video gets uploaded into Field Service Lightning. This is where the AI takes off. So once you take that video and you upload it, this is where our AI and our autonomous monitoring kicks in. So this is an early model of ours. I'm going to show you a movie here. But before we get to the movie, I want to orient you to this. This is one of our earlier models, so you are going to see it fail. I think it's important. As a person working in AI, I want to show you all failure. I do believe it's hard to make things work. And I also, like, if something seems to work too well, then maybe it's not quite true. So you will see this fail. Essentially what you're going to see, so here we have a shark with a box around it, and you see a number. That's how confident the AI is that this is actually a great white shark. So you'll note the box there. Watch what happens to the surfer. It's kind of funny. And then to the right, you're going to see a piece of kelp. So right now, that's a piece of kelp. So the way we trained the AI is essentially we had to take a lot of movies like this, and it's called annotation. But we literally drew boxes around all these sharks. And we've had a big team of people spend just countless hours, days, and weeks annotating this. And this gets back to deep learning. We fed these videos in saying shark, not shark, shark, kelp, seal. And after the machine sees enough of that, it starts to understand it. And so not only are we looking for sharks, we're looking for great white sharks. And the thing is, you're going to see a lot of leopard sharks out there. But they're different, and we've been able to train the AI. So check out the video. Let's see. Surfer notices it's a shark and then starts hauling the other way. You're also going to see this on the kelp. So what we actually did, the early version of this AI actually thought that was a shark. But you'll see it's a low confidence rating. It's a 0.5, so not really high. And then with additional annotations, we were able to break it of that bad habit. But I think this is super interesting as you're working with deep learning. And as Z's going to tell you in a bit, you guys can do this. You can literally leave this room really soon and build your own model. But you'll encounter things like this of your model basically does things you don't want and you have to correct for it, and that typically comes back to you need more training data. So that's a quick view. We have improved the model dramatically now, capturing great white sharks. Our current challenge is we're trying to determine shark size. Because as I said, when we got out of the building, what we realized that lifeguards and store owners and everybody else was concerned about was not just the presence or absence of a great white shark, but the size. They wanted to know the size of the shark. And so that's rather challenging to do. That's what we're currently working on, is getting size predictions in there. But that's also the value of get out the building and talk to your end customers. So once the video is uploaded, the AI automatically analyzes it, captures the counts and the locations and everything, and pushes it back into Field Service Lightning. And this is where we kick off different workflows. And so our first workflow is a danger workflow. We essentially say, is there a high shark population in an area? If so, we can send messaging out to particular users, to safety workers that may patrol that beach, so that they're aware of that high shark population. From there, we'd go down the litter, and I'm flagging this as a future idea, which I'll tell you why we're not doing it right now. We could also imagine a scenario where if we saw a lot of litter on the beach, we could dispatch cleanup workers to go pick that up. And then ultimately, we're taking all this data and we're publishing it to a public website for marine biologists to better able to understand this phenomenon of why are there so many sharks here, what time of day, what time of season, et cetera. So we're making this data available to scientists so they can better understand this challenge. So if you were a safety worker, you might imagine getting a push notification like this. Imagine the lifeguards having this app and just saying, hey, there's a high shark population at a particular beach. And you could also imagine a safety worker going out and flagging the beach. And so this is how we dreamed about it. However, again, we got out of the building. We went and talked to the lifeguards. And they said, no. We don't necessarily want to post the beach. We don't want to cause mass hysteria because, face it, sharks are part of the natural population. They're always there. So working with the lifeguards, they're not necessarily going to go post it like this. They really want it for situational awareness. But you could imagine this flow being played out. Particular worker gets notification and then goes and takes action on it. Using flows, ensuring consistency of the posting of the beach. Beach cleaner, this is a future idea. And ethically, the reason why we didn't do this is it had a lot of ethical and legal concerns. So it is one thing to point your camera down at the ocean. It is another thing to point your camera over at the beach, on the beach or where the people are. And imagine orchestrating lots of people. That falls into mass surveillance. Not only that, what happens if you film something on the beach that was illegal? What's your reporting structure look like that, et cetera? So as you can see, actually trying to analyze the beach was fraught with legal and ethical concerns. So we've chosen not to implement that. However, you could see the same technology being applied here, where essentially using the power of the platform, we could count how many pieces of litter are on the beach. We could define a threshold at this is too much litter, and then we could send a notification to get cleanup workers to go up and pick that up. So that was sort of another way we sort of thought about this program. So as far as ethical, I'm really happy to say we have a woman named Kathy Baxter. She's our ethical architect. I get to work with her quite a bit. You might have seen her. She's all over the news this morning because we launched a new ethical trailhead yesterday. And so it's pretty great. We don't just do ethics as what bookends. We actually try to do it through the whole project. So at the beginning of the project, we talk with Kathy. We explore the possibilities, the middle, and the end. So it's not just something you do at the end. Like Kathy always says, ethics is a mindset. It's not just a checklist. And so this is the framework we typically look at it: the creation, the implementation, and the usage. So from the creation standpoint, when we created this AI, we never labeled humans. We only labeled sharks. So our AI knows nothing about humans, never taught about humans. The sourcing of the training data, having permission to it, collection, building your own training data. So ultimately the creation, implementation, and uses, we had to go explore, what did she call it? Sometimes, someone did something alarmingly stupid, such as what if instead of they were counting sharks, what if they're trying to hunt sharks? Like, could this be used as a shark hunting device? Or what if we messed up and instead of one drone pilot showing up on the beach, what if 100 showed up? What would that experience be like on the beach with all these drones? So as you build technology, I encourage you to really think through what would happen if somebody used this, misused this? What are ways we do not want people to use this? Think about your creation process and think about the usage. I mean, that came back down to if we had video, if we captured on video something illegal going on, we had to go report that. And like, what's that mechanism look like? So I'd always encourage you to sort of think more deeply about that. It's pretty fascinating. It can also be kind of scary. So unpacking it a little bit of like, well, MJ, that's cool. You got field service light and you got some AI, but how does it work? So let's get into the nuts and bolts a little bit more. Essentially, we took field service lightning As that data is collected, we then shuttle that over to what we call Einstein Vision. This is actually a special model that we built just for this application that counts sharks. And so essentially we shuttle that video over, this piece of AI then cuts it down by frames and analyzes each frame, and then it reports that data back into Field Service Lightning. And we did have to solve a few technical challenges. Basically, I mean, if you think about it, the shark is moving, the drone's moving, the waves are moving, everything's moving. How do you avoid double counting? How do we avoid having what's actually one shark and reporting it as 30 sharks because it keeps swimming in and out of our frame? And so that was a big challenge we had to solve, and we came up with two novel approaches. The first is re-identification. So essentially, when we do find an initial shark, we store unique characteristics about that shark, so that if we see that same shark later on in the frame, we count it as a single shark, not as a double shark. In addition to that, we've done what we call trajectory mapping. So we've taken the trajectory of that shark, we've continued to predict where it's going, we then take all the video, all those frames, and we lay them out like a panorama. So ultimately, we're able to see where the shark is traveling, so that if it appears in that swim path again, we know it's the same shark. So this was one of the big challenges we had to solve from the research, was essentially how do we avoid double counting when everything is moving there. I also wanted to give a big thank you to these folks. It's great that I get to come up on stage and talk about this, and Z gets to come up and talk about this, but I think as many of you all know, these things are not one person. These things do not happen overnight. This has been a long time, and this is essentially a small team that has helped us build it. So across the top row, a lot of the folks from the Field Service Lightning team. And that's what I really love about our company. We all have our day jobs, but we all like building cool stuff and doing good in the world. So when I approached the Field Service Lightning team with this idea, they were all over it. So Uri, our VP, said, yes, I'm in. Brought in this amazing design team, Sheila and Adrian. Also our SE, Chris, a solutions engineer, is so valuable, setting up this application and experience, helping us go through it. The whole AI model, which was written by Xiaobai down there on the bottom, actually had to be wrapped into its own service. And so this is where AI engineer Adashar came in. Ultimately, nothing happens without legal. And so legal, I sort of think about it as code. You want to do it early and often. And so working with legal, you can imagine approaching your legal team and saying, I want to use sharks and drones and go fly. You know, that most legal teams would just pass out right there. But our legal team really leaned into it and said, well, these are things that we need to consider, and how are you going to safeguard against X, Y, and Z? And then ultimately, some of the folks from BOI who assisted us with this, and then Kathy Baxter, our ethical architect, Z, who's going to talk to you in a minute, and our wonderful product marketing manager. PMMs, I think, are some of the unsung heroes here at Salesforce. They make all these beautiful slide decks, great talk tracks, and then somebody else gets to come up and do it. So this is a team that helped put us together. Really appreciative of that. And ultimately, when we combined this technology and we get the right people to go do the right thing, results in the happy shark dance. So with that, I want to bring up Zineb Laraki, also known as Z, one of our senior product managers here at Einstein.ai.
Awesome. Thank you, MJ. I think we all love to hear about, how Salesforce is helping, make the world a better place. That's one of my favorite things about working here, right? It's like how well Salesforce values align with my values of wanting to make, a better world. I also know that, we're a for-profit company. A lot of you are wondering, how does this matter to you? And actually, a lot of customers, a lot of developers are coming to Salesforce asking for help with computer vision. So let me just walk you through a few use cases to spark your imagination here. We have customers in the energy space that are asking for our help to identify if poles are tilted or if lines are susceptible to start fires. So you can think about not only the financial benefits here, but also just like the number of lives that could be saved. In agriculture space, we have customers that are interested in understanding overwatering, underwatering, pest management. In transportation, we have customers that want to understand logistic, traffic, or security video analysis. We have customers that want to understand what are the trucks that are showing up to their factories based off of the codes that are written on the outside. So a lot of use cases, a lot of customers are coming to us. And really, I'm going to explain to you our process so you can better understand how we work together. It first starts with an idea. And this idea can come from anyone. It can come directly from customers, and oftentimes it does come directly from customers. It can come from someone at Salesforce. It can really come from anyone in the Ohana. Once we have an idea that we're like, okay, like let's figure this out, we turn to our applied research team. So as MJ was mentioning earlier, our applied research team is focused on really finding AI models for our CRM use cases. And so they go and we try to see, can we build a model that works? Can we solve this problem? Once we've validated that, yes, we can solve this problem, which isn't always the case, but when we do, we then turn to our AI engineering team. And they have the very hard job of hosting these models, making sure they scale, making sure we uphold Salesforce trust and security, and so really making these models accessible and available to all of you and everyone in the Ohana. And at that point, we start piloting these models with customers. We also start piloting them with internal clouds. Because one of the things that we realized is not only are the models valuable and helpful for customers, customers also really want to integrate these into applications. And so we want to make it available to you guys to integrate into applications. We also want to make it available to clouds to be able to integrate them into applications. So really end-to-end use cases. And of course, this then generates new ideas and the cycle goes on. And at the core of this is really ethics, right? It guides every decision and every product decision that we make. So with that, let me walk you through one example, a recent example. We had a lot of customers come to us asking for help with a similar use case. So we had a customer asking for being able to understand VIN numbers in pictures. We had a lot of customers asking to be able to digitize documents or legal contracts. We had construction companies asking us to understand schedules, printed schedules, and the list goes on and on. But basically what all of these use cases have in common is the need or the desire to understand text and images. So that's also called OCR, or optical character recognition. And so we're like, great, I think we can solve this problem. So we turn to our applied research team and ask them, can we solve OCR? Can we have an OCR model specifically for our customer use cases? And as of a few weeks ago, we're excited to announce that our model, our Salesforce model, is performing better than what's out there in the market, better than Google and Amazon. And so we're really excited. We have a lot of potential here to really help our customers. And so at this point, we're starting a pilot. And so if any of you guys are interested, you can have your account team nominate you for the pilot. And we're also piloting it with internal clouds. So we're talking to the Salesforce Health Cloud to be able to integrate this technology, to be able to automate patient referral documents. We're talking with Quip to be able to digitize documents and contracts, with field service, augmenting their QR code reader with a serial code reader. And then with mobile, looking at automating contact creation from business cards. And these are just a few of the many things that we're looking at, but you can kind of understand the process that we go through here from this one example. We talked a lot about vision today. I also want to kind of share that our team also works on a few different services. So we also work on language as well as voice. And we actually have a few services that are available to you to use right now. And we have customers that are currently using these services. I'm going to walk you through them, and I'll point out which ones are GA. And I'll also explain some of the use cases that we're seeing some of our clouds use. So under vision, we have image classification. So that's our first computer vision product that we launched. And really what it allows you to do is define categories, and then given an image, it'll tell you which category it belongs to. And so we worked with Social Studios. So Social Studios is part of the Marketing Cloud, and they basically analyze social media, right? And so we worked with them to create a model to understand scenes. So beaches, boardrooms, et cetera. And with that, they can now provide this to their customers who are able to understand where do their products show up, where are their customers taking pictures of their products. So that's one use case for classification. for object detection, that's our second computer vision functionality. And that allows you to train a model to understand products in images. So how many of you guys have heard of the retail execution use case? We've talked about this a bunch. Okay, one person, two. So let me walk you guys through this. But basically, a lot of consumer good companies right now send people out to the stores to be able to audit and make sure that their products are showing up correctly, right? Because they pay a lot of money to, what shelf, what the display looks like, et cetera. And so they're sending people out to all these stores to monitor and make sure that this is actually done correctly. And so actually this came from a customer. A customer came to us and was like, we want to be able to use computer vision to solve this problem. And so we went through the process I just explained, and now we have a Salesforce cloud that's building a retail execution application. So being able to not only do the computer vision part of it, but the whole end-to-end process. And computer vision is going to be one component. And so with this, when people go out and do store audits, now they can simply take a picture and it'll automatically understand the products that are on the shelf, so on-shelf availability, share of shelf, as well as planogram compliance. The industries team, the retail execution team, is also looking to use sentiment. So sentiment is one of our NLP products. And what it allows you to do is basically given a piece of text, it'll tell you if it's positive, negative, or neutral. And so they're wanting to use it for survey analysis. Intent, which is our second NLP product. NLP stands for natural language processing. We're trying to make sure we unpack all the acronyms. Chatbots is using intent. So a lot of you have probably seen the Salesforce chatbot. So they both use intent as well as their NER. So intent basically allows you to define categories, and then given a text, it'll tell you which category it belongs to. So is this password help? Is this a delivery issue? Et cetera, right? And so you define those categories, and then it'll tell you, when a customer gives you that text, it'll tell you which category it belongs to. NER, which is name entity recognition, it tells you what part of speech each word is. So is this a name? Is this a date, a location, et cetera? And so that's being used by chatbots. And it's actually also, intent and NER is what's being used by Einstein Voice Assistant, which was one of the big Dreamforce announcements. So hopefully a few of you guys have seen this. If not, just around the corner, this is being demoed, so you can check it out. Einstein Voice Assistant also uses transcription. So transcription basically takes audio files and turns them into written text. And that's also what's being used by Converse. And so most of these products, actually, the first 4 here are generally available for you to use. And so we have documentation, and you guys can start using them. And I'm going backwards. I'm like, where are the slides? And actually, we already have customers that are using them. Oh, now we go back. So we have customers that are using object detection to understand products as well as parts. So they're building their own models and integrating them into their applications. So when they're sending field service people for parts to be able to identify them, or sometimes directly have customers being able to take a picture and understand what it is. One example is a garage company, the garage clicker opener company, was having customers keep asking for, they lose their clickers or they break, to being able to open their garage doors, and they don't know what model they have. It's hard to get to, and so they would have to send technicians to figure it out and all this stuff. And now simply the people can take a picture, and it can just be automated completely and send them the right clickers. We have customers using object detection to understand car damage and severity of damage. So Auction Nation, one of our customers here, has announced that this has like so much revenue saving for them, because now they kind of just automate all of that claim processing. We have customers looking to use it for case routing, so automatically triaging when a case comes in, which category does it belong to, who should it be sent to. And then survey analysis, which we talked about already. So with that, how do you guys kind of start using these products? There's documentation on Einstein.ai. It's free to get started and to sign up. So, and you can go ahead and start playing around with these today. So just go to Einstein.ai and sign up for them. And there's documentation as well. That's awesome documentation. We had someone at Salesforce post that their 10-year-old was able to build a model just following it. So it's just the first step, but great to hear. We actually also have a UI that we just launched that's available in App Exchange. And so that's also one avenue that you can go. If you don't want to play around with the APIs, you can use the UI. And then we have getting started booklets as well as some decks to kind of walk you through best practices. Because the first step is understanding the products and kind of building your own model. But then really it's like, how do you make sure that it works for your use case? How do you scope your project correctly? So I'm going to take just,
Awesome. Thanks, Z. Cool. So I think as you all can see, there's a lot of AI power tools available for you today for free. And so ultimately, I'd encourage you to go check those out, dream big, work together, and go create a better future with AI. Thank you all very much.
We have a few more minutes. If you guys have questions, there's a microphone right there. So I'd love to hear from you.
Or you can come up if you're shy.
Yeah, if you're shy as well.
Awesome.